Hi Chem Peeps. This is video 2 in thermodynamics, and we're going to look at some examples of answering questions about reaction energy curves. You can see on the left side I have an equation, A plus B forms C plus D plus heat. Now the heat is on the product side, so going forward this is going to be an exothermic reaction. Okay, and they give us two graphs, graph A, where we can see the reactants and products, and graph B, reactants to products. We can see that there's an energy quantity here listed, and we have some questions to answer. So question A says, identify the reactants and products on each graph. Now the graphs, if you look at them, and we're going to answer this later in F, but they're mirror images of each other. We're only given one reaction. And if you notice, the energy quantity in both of these is 200 joules. So somehow these reactions are related to each other. Actually, one reaction is the forward direction of the reaction they give us. A plus B gives us C plus D plus heat. And the other reaction is the reverse of the same reaction. C plus D plus heat gives us A plus B. So let's identify the reactants and products in both of these problems. So looking at the first graph, you can see we're putting way more heat into, or energy into, the curve, and then a little bit coming out. This is actually going to be an endothermic reaction because there's more heat going in than coming out. Likewise, in part B, we have a little bit of energy coming in and lots coming out. So this is an exothermic reaction because more heat is coming out than in. So if we label the graph, the reaction that was given up here in the forward direction is an exothermic. So the reactants in this one is going to be A plus B, and the products in graph B are going to be C plus D. Now, the reverse reaction, our reactants are going to be C plus D, and the products are going to be A plus B. Okay, so question B says, which graph shows the enthalpy change for the formation of A plus B? So where are we forming A plus B? Well, that would be graph A. In graph A, the A plus B are considered the products. Which graph shows the greater energy of activation? Now remember, energy of activation is the energy going in. And if we just look here, we don't have any values, but you can see that in graph A, we have way more energy going in. Therefore, our energy of activation is going to be A for the most. And in question D, it says, what is the value for the enthalpy change in each graph? Well, it's 200. In 200, so enthalpy, which is labeled delta H, is going to be the products, doesn't want to write on here. It's going to be the products minus the reactants. And so if we look here, the distance between the products and the reactants is going to be 200. Now, the sign for them in an endothermic reaction, which would be graph A, it is going to be a positive 200. And in graph B, which is exothermic, it's going to be a negative 200. All right? And then explain why the two graphs look different. Well, they're mirror images. One is the forward reaction, one is the reverse reaction. So they're just reverse reactions of each other. And I didn't tell you in the first slide I did, or the first video I did, the distance between the top of the curve and the reactants. In other words, the activated complex minus the reactants is going to give us the energy of activation. We didn't have to calculate that, but I thought it would be important to explain that once again. Okay, so we'll go to another problem in the next video on energy curves for reactions. Find me on TikTok and YouTube at Chem's Chem Chats.